Okay, fourth graders, we're going to look at prime and composite numbers. We're going to look at actually finding the factor pairs of a number, okay? And I've already given you the number. So the number that you're going to be doing is this. So please write 36 on your whiteboard. And then draw your T-chart, please. Okay? So now you already know that 36 is the number that you need to try to find all the factor pairs for. So you could build... Sometimes people do factor rainbows, or they'll do a factor T-chart. I usually do a factor T-chart. It just helps my students really see the factor pairs, okay? Now, on this video, I am not going to have you find all of the flip-flops, okay? Once you hit the turnaround point, you can stop, okay? So you always start at 1. Okay, so once you have 36 written on your board, you will start at 1. Sorry, I kind of get it readjusted here. You're going to start at 1, okay? And you're going to say, I have 1. So 1 times something equals 36. So you know that 1 times 36 equals 36, because that's your answer, 36. So now you have to ask yourself, what times 2 if 2 works? 2 times what equals 36? Well, if you said 2 times 15 is 30, 2 times 15 is 30, because 30. 15 plus 15 is 30. So you know that you're going to get close. So 15, so 16, 2 times 16, 2 times 16, so 2 times 6 is 12, and 2 times 10 is 20, so that'll be 32. So 16 doesn't work. 17, so 16, 17, so 2 times 17, so 2 times 17, so 2 times 7 is 14, 2 times 7 is 14, 2 times 10 is 20, so that'll be 34. That's closer, but not quite. And then how about 18? So 18, if you double 18, well, that's going to be 36, so that'll be 18, okay? So 2 times 18 equals 36. How about 3? Does 3 times anything equal 36? Well, 3 times 10 is 30, and 3 times 2 is 6. So then I know that that'll be 12, okay? How about 4? 4 times anything equals 36. Let's think about that. Well, 4 times 5 equals 20. 4 times 7 equals 28. Okay, 4 times 9 equals 36. So, yeah, that works. 4 times 9, okay, equals 36 as well. Right now we haven't hit any doubles or any flip-flops, so we can keep going. 5 times, does 5 work? So we'll ask ourselves, does 5 times anything? Well, 5 times 6 is 30, and 5 times 7 is 35, and 5 times 8 is 40. Nope, 5 will not work, so 5 cannot work, okay? 6 will work, because 6 times 6 is 36. Now, once you've hit a double like that, you can stop. Because doubles tell you, once you hit a double, you've found all the factor pairs that you will ever need to find. You're done. Once you've hit a double. Now, not all numbers are doubles. Some have near doubles. But this one has a double. 6 times 6 is 36. They're called perfect squares. So, how many facts? So when you look at this, you're going to be like, oh, okay, well, I already know that this is going to be, is it going to be prime or composite? Remember, prime only has one factor pair. Only one factor pair. This has 1, 2, 3, 4, 5 factor pairs. So composite has two or has more than, composite has more than one factor pair. So more than one factor pair. So 36 is going to be composite because it has several factor pairs. It just doesn't have one in itself. Okay? So hold on here, we'll look at it. So now we're going to look at another number, and this number happens to be 17, and we have to decide, is 17 going to be prime or composite? We need to find all the factor pairs of 17. So we start with 1. 1 times what equals 17? Well, 1 times itself equals 17. So then we move on to 2, and we decide, well, 2 times 6 equals 12, 2 times 7 equals 14, 2 times 8 equals 16, 2 times 9 equals 18. Well, this 2 will never work because 2 skips over 17. It goes from 16 to 18. So 2 never works. 3. Does 3 work? 3 times 5 equals 15. 3 times 6 equals 18. It skips. So 3 does not work either. Okay? Does 4? Well, 4 times 5, or excuse me, I'm going to go smaller. 4 times 4 equals 16. 4 times 5 equals 20. 4 doesn't work either because it skips. 5 times 3 equals 15 because it gets me close. 5 times 4 equals 20. Nope, that skips. And besides, 5s never end with a 7. So that would never work. 5 would never work ever. You could just do that without even skip counting. 6, well, 6 times 2 equals 12. 6 times 3 equals 18. Doesn't happen. That one doesn't work either. 6s don't work. Okay, how about 7? 7 times 2 equals 14. 7 times 3 equals 21. Nope, 7s don't work either. How about 8? 8 times 2 equals 16. 8 times 3 equals 24. Nope, that does not work. Okay, how about 9s? 9 times 2 equals 18? Nope, because 9 times 1 equals 9. That'll never work. So here's 10. Well, 10, 20, 10 doesn't work. 11. 11 times 1 is 11. 11 times 2 is 22. That doesn't work. 11 doesn't work. 12 does not work because 12, 24 skips over. 13, 26 doesn't work. 14 doesn't work. 15 doesn't work. Well, the only thing that you have would be the flip-flop, which would be 17 times 1, and I'm not going to write that. So this one is going to be a prime number because it's only one factor pair. Okay? Because the other is the flip-flop, and I'm not going to even write it because it's the same problem. So 1 times 17 means it's prime. There's only one factor pair. Okay. If you have questions or concerns, let me know. This one is hard. 4th graders struggle with prime and composite and finding all the factor pairs.